In this video, I'd like to talk about the math question of the day for Friday, August 18th, 2023. And with this problem, we are given a function, g of t, and we're asked, what is the average rate of change of g over the interval from t values of -4 to t values of 5? And questions like these, asking about the average rate of change, are typically seen for the first time in a pre-calculus class, though you may also see these in Algebra 1 or Algebra 2, depending on where you go to school. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And before we jump into the specifics of this problem, let's just think about what average rate of change is actually asking for. Let's say we have a coordinate plane and some random function, which we can draw on here. We can call this function f of x. And the average rate of change is essentially asking us between two different x values. In this case, we can say x1 and x2, how is the function changing? And this will just tell us an average of how it's changing. It won't give us an exact value. Let me actually write this maybe over here so it's more distinct. But this will give us a rough idea of how the function is changing. If we look at the point on the curve, this will be at f of x1, and this point right here will be at f of x2. We can see that going from one point to the next that it's increasing, but to find a mathematical way to express that, what we can do is draw a line between these points and then find the slope of that line. We can find the steepness of the line connecting these points. So let me draw that in, and it won't be perfectly drawn, but we can get a rough idea. Now this line here is what we call the secant line, and we need to find the slope of this line. We need to find how steep this is, and that will tell us roughly how the function is changing. Though you can see it won't tell us exactly. If let's say this slope here, it has a value of 1, that roughly tells us that as x goes over 1, the function goes up 1. But as you can see, the function decreases first and then goes up fairly steeply. So this average rate of change is missing information. And if we want to know exactly how the function is changing, the exact rate of change, for that we need calculus, and we need what's called the derivative. Essentially, we will just make these points get closer and closer to each other so that we don't have a secant line, but we have a tangent line where it just touches at one point. And if we drew in that tangent line, which maybe will look something like that, the tangent line will tell us exactly how steep the curve is at any given point. But with an average, we need to look at an interval. We need to look at two different independent variable values. So let's focus on finding the slope of this secant line. We can say that the slope is the change in the function values divided by the change in the independent variable. And we can see that the function, the change in the function values, we are at f of x2, and we will subtract f of x1. You might remember the slope formula, y2 minus y1. This is effectively the same thing, but we're finding how much the function values change, meaning we are finding this length right here, which means we need to find the difference between the two function values. And then we divide by the change in the x values. Again, we're finding a difference, essentially this length right here. We take the larger one, x2, and subtract the smaller one. This right here now is what we call the average rate of change. This is the formula for that. Though in our function we have g of t, so our variable is t here, but this will work the same way. And we have t at two different values. We have its lowest value and its highest value. So we need to find the function evaluated at these two different intervals. So let's start with t is -4. We can plug -4 into our function. We get the opposite of -4 minus 1, which is -5. We square that and add 5 to it. this becomes positive 25, but then we take the opposite, and minus 25 plus 5 would be minus 20. Now we do the same thing, but with a t-value of 5. We find g of 5, and plugging in 5 here, we get the opposite of 5 minus 1, which is 4, which we will square and then add 5 to that. This becomes minus 16, and minus 16 plus 5 would be negative 11. So we have our values for the numerator, and we can also plug in our t-values for our denominator. Essentially, in this formula, just replace x with t. So we'd have t2 minus t1 and f of t2 minus f of t1. So let's now make some room down here, and we can plug in our values to this formula. We have the average rate of change. I'll write that as ROC. This will be equal to the slope of the secant line over these different t-values, but we're just using this formula at this point. We have f of t2, which is the bigger t-value, and of course we're using the function g, not f here. So g of t2, g of 5, we know that is negative 11, and then we subtract g of t1, or g of negative 4, which is negative 20, and we are subtracting a negative. And in the denominator, we take the bigger t-value, which is 5, and subtract the smaller t-value, which is negative 4. Now, in our numerator, we have minus 11 plus 20, which would be 9. And in our denominator, we have 5 minus negative 4, or 5 plus 4, which is also 9. So our average rate of change over that interval is positive 1. And the way to interpret this is that we can write it as a fraction and compare it to slope. Remember, slope is the rise over the run, if we define it like that. And effectively what this means is that every time t increases by 1, on average, the function will increase by 1, or the y values will increase by 1. So on average, between those t values, the function is going up. However, keep in mind that over that interval, the function might be going down first and then might be going up more steeply. So it might look something like this, but it averages out that every time t is increased by 1, the y values increase by 1 as well, or the function values increase by 1.